Hi, and welcome to this AI and C# video on the Microsoft Agent Framework. Today's topic is Retrieval Augmented Generation, or RAG for short. And Agent Framework by itself actually can't do RAG because it doesn't have any features for vector stores or embeddings and such. But since Agent Framework is built on top of Microsoft Extensions AI, it can easily leverage its embedding generator, and then it don't want to choose for you how you use your vector stores. So it leaves that up to the user. And in my case, I'm actually gonna use semantic kernels vector stores because they're not really connected to semantic kernel itself. They're just there by name. But we will see that in 1 second, and they are still the best in the market, in my opinion. So here we are in Visual Studio, and the scenario today is that I have made some made-up movies. I made ChatGPT do that for me, and it made up this list of JSON where I have 100 movies with a title, a plot, and a rating. The reason why I chose this is because RAG is all about business data, and it's if we just talked about things that are in the world knowledge, like real movies, the AI might begin to use its world knowledge instead of this. So I needed something unique that it couldn't know upfront. So I take those and I turn them into objects. So I just have an object for the same with the title, the plot, the rating, and a little method to get it as one big go. And then our question for today is we're gonna use a question says, what is the 3 highest rated movies, adventure movies, and we want to list them by plots and ratings. So this is the question, and then we're gonna make our Azure OpenAI client like normal. So first up, we are gonna try and ask an AI, and we say it's an expert in the made-up movies, and I'm stressing to it that it's not allowed to use its world knowledge. And the first scenario, sample 1, is where we give it all the movies up front. This is not actually RAG, or it's poor man's RAG if you want. But we can just load it up in messages as if the user said in, here's all the 100 movies. Now give me the answer back to that one specific movie. So that's what we're doing here. We are loading them up and adding the question at the end. So we send up 102 different messages. One is, here's all the movies. 100 of them is the movies. And then we have the question as the final one. And if we do that, we end up with a question or an answer. And this might be the best list we can ever get in this example. The problem with this way of doing things is we spent 7,696 tokens on this because we loaded so much data up front. You might say, okay, that's okay. But imagine you had 1,000 movies, or you needed to have all the movies in the world because they were not, for example, in an AI. So this can easily cost way, way too much, but it is actually the best thing because it had all the context of all the movies, and we will never be able to do that better with RAG because RAG is a subset of data. But this was the simple way, the cheap and dirty way. Let's see another way. So sample 2, we are gonna use Microsoft Extensions AI embedding generator. So we can make one of those using our client we made our agent with, but we can just say get embedding client instead. And in my case, I'm using OpenAI's text embedding tree small. There's a few different embedding generators out there. And then I'm getting it as an I embedding generator. Then I'm gonna turn it into a vector store. And in this case, I'm using Microsoft Semantic Kernel's connector in memory store. So right now I'm just loading it up in memory, but of course a real vector store would be Azure OpenAI AI Search, Cosmos DB, Quadrant, SQL Server, or whatever. I will show some samples of that later. And you might be saying, okay, why are we using semantic kernel? That's the old thing. If we look into this, let me quickly stop the code so we can run it to here again and be able to see our NuGet packages. We will see that the installed NuGet package, which is this in-memory thing here, and if we look at it, what its dependency is, its dependency is Microsoft extension vector data. So this is a little like Microsoft extension.ai. It's a common set of ways to working with vector data in .NET. So it's using that and using dependency injection, and it's using some tensor thing here. So it's actually nothing to do with AI. It's nothing to do with semantic kernel. It's just because semantic kernel made it first. In a perfect world with a time machine, Microsoft would go back and call this this package Microsoft extensions vector data in memory. At some point, they might change that name to that name. But so we are sitting here and working with something that are in spirit semantic kernel, in namespace semantic kernel, but it has nothing really to do with semantic kernel. So it's not like we are using something that are going away that are in maintenance mode. Not at all. It's still the best way of doing it in the system. And if you don't want to do this, you can go out, you can take out the vectors yourself using the embedding generator, and then from there go in and store them manually in one of these vector stores. Because let's run it to here and talk a little about other vector stores. So, for example, Microsoft Semantic Kernel connectors. Let me get down here again. We can get Azure AI Vector Store, which is Microsoft's corporate version of it. It's free for a limited amount of data, and then it becomes actually very expensive. So up to you if you want to do it. But if you use it upfront already, it might be a good choice. So right here, I'm just newing up and giving the vector generator in. Had it been the Azure AI Store, I would have done exactly the same, but I've just needed to tell where's my endpoint and where's my key. And in the same manner, had it been a SQL server, you need SQL Server 2025 or higher, you would have given a connection string. And had it been Cosmos DB, you would have given the connection string to a Cosmos DB and what database that should use. So this is a abstract just as an LLM that can go against OpenAI and Google and so on. This is just a vector store that can go against in-memory, Azure AI, SQL Server, and so on and so forth. So we're just going to use an in-memory, so it's easier to understand and we don't need to begin to talk about these. If you want me to make some videos about this, I can definitely do that as well. Tell me that in the comments. But what we're gonna do is we are gonna, let me give myself a little more room here. We're gonna make a in-memory collection with a grid as a key and a movie vector record as our records for this. And we're gonna call it movies. And this record here is just a class with some extra attributes on. So we're going to tell this is the key in the vector store. This is data in the vector store, so just normal columns. and this is the vector itself, and the vector will be comprised of the title with the title in, the rating. So this is what we are actually gonna embed. And then it has a little helper method that I'm gonna use a little later on. So right now we are working with 1536 dimensions, which is kind of the default. We're using cosine similarities, and the index kind is here as well. So this is more vector information than AI, but we're going to make that collection. And right now that collection is empty. It's not actually not even existing because we need to call ensure collection exists async. So now we have a collection. It's in memory, but had it been one of the others, it would have connected to that remote source. And now we're going to take our movies, all 100 of them, and embed them. So the collection itself have an upsert that can put this in. We're just using NuGet, so it will always be inserts. But given that it's in memory and there's no data, else you need some strategy to get the same IDs. That could be the ID of the movie, for example. But it's going to do this, and every time I call this, it's actually going to make a call up to Azure AI and do the embedding, give me a vector back, and then put that into the system. So I'm gonna just let this run, and it will take a little while. I put in a little counter here so we can see it happening. So vectorization is not expensive, cost a little, but it's not too expensive, and it's fairly fast. And of course, you wouldn't do this before the question. You would have this as a separate service, embedding all your data, and then have another app that actually did the search. But in my case, it's the same process here. But we're done with the embeddings. So let's ask the question. And in this case, we're gonna put in some data up front. So we are gonna use the collection and search for the text of the question, which was the 3 highest rated. And among the 100 things in the collection, we're going to take out the 10 most similarity searches. And this is not AI search, it's similarity search. So if we go in here and search, we'll get the first search result back. And in this case, it was one called Frozen Labyrinth that had the most related to the question, which had the words adventure, it had movie, it had, different things. And what we will see is we will end up with 10 of these. And if we set a breakpoint here, we now have, instead of 102, we have 12 things here. We have here the most relevant movies, the 10, the search found, and our question. And what will happen is the best movie might not be here, because the best movie is all about the highest rating and such, while a similarity search can only talk about text. So that is the drawback of a RAG. That we could have said we wanted 100 of them, but that would defeat the purpose, and we could just have run sample 1 anyway. But so RAG will never be as good as giving all the data in the world to the LLM, of course. But this is the best way we can do it in such a scenario. And what the benefit of this is, of course, is that we get our answer back. It's not the same answer because, again, among the 10, the best movie, the one that had 9 point something, might have not fit the similarity search. But it costs us a fraction of the tokens. And that is the thing you need to figure out. How much should we go in and say we need to get 50 of the movies then? Because then there's a bigger chance to get them. But it's all the cost versus and the time versus how we search. Because again, we could have 10,000 movies, and that would be way too much to load up front. So RAG is good, but it will never be as good at giving the entire volume of data. But we're getting a pretty good answer. Now let's see a sample tree where we do something very similar, but in this case we're gonna make a search tool. So we're gonna make a tool that the AI can use as a tool call instead of loading it up front. And the reason why that is smart is that, for example, if the user, if it was a chatbot and the user just says hello, it would not make sense to find 10 movies with the word hello in it and then just answer back, hello, how are you? So searches for a RAG is often done using function calling. So if we make a tool here and we take our search tool with our search vector, we now have an agent that both that have that tool available, meaning it has RAG capabilities. But if we ask hello, it will not use it. If we ask what is the top the 3 movies that are best in adventure category, it will use it. So in this case, it will make a tool call. So it went in here. That's my middleware telling me that. If you're not familiar with tool calls, then see the tool call videos that are dedicated for that. But we get a response back, and we get exactly the same response because, again, the similarity search is the same here. And again, it's only from the 10 of the 100 that were most similarity in text that we get back. That's the drawback again of RAG. But we end here, and the data is back. We can see we used more input tokens. That's because the input also had the definition of our tool, so that cost a little bit more. So sometimes it makes sense to do things upfront if it's a purpose-built tool that will always answer a movie question no matter what. While it's a chatbot that can say hello and what is today's date and whatever we need to ask, then it's better to have it as a tool call. So to sum up, if we give all data up front, we get the best answer. No questions asked. But it's not really RAG, and it's quite expensive, as we saw with like 7,000 tokens compared to 1,000 tokens. We then can make our embedding generator, and it has nothing to do with agent framework as such. It's Microsoft Extensions AI that does it. And whatever we want to do with these embedding generators, because embedding generators can also just say generate a sync and take some kind of value and turn it into a vector. And then we could use that vector to store in whatever tool we wanted. But Semantic Kernel, the previous team, have made these really good vector stores in this shared Microsoft Extensions vector data namespace that can just take the embedding generator and embed the data. And this is a really, really solid way of doing things with multiple vector stores. So we get our vectors stored right now in memory, but just as easily with the same code after the fact here in SQL Server, Cosmos, Azure, or any of the other. I think there's like 10 or 15 different. But if we do it that way and search for it, we will see that our quality of our search will not be the same unless we actually take out 100 and then defeat the purpose. So I think I will end it there. Hopefully it's clear now that yes, while Agent Framework itself doesn't have anything, it just leverages all the goodness that are already out there, and it makes sense that it should focus on being an agent framework and not a RAG framework. So that, thank you. See you in the next one.